Hey everybody, this is Larry. This is day 28. Nope. Day 27 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. I don't know. Apparently I don't know what day it is. I'm in a lot of pain right now. I don't know how, but my foot just keeps getting worse. I hope I don't have to amputate it because that makes it hard to run or even walk. Anyway, it's not a great situation, so I'm gonna see a doctor probably soonish. I don't know what maybe my diet's not that great. I've been eating a lot of sugary, or just not even sugary, just carbs. But in any case, yeah, I don't know what's going on with my foot. There's a bruise. It's swelling. It keeps getting bigger. Yeah, no bueno. But anyway, it's actually a very nice day for running today, but I didn't do any running. I just gotta stay home. And what did I do? I don't know what I did. It's okay. It's fine. Anyway, let's look at today's problem. 1462, course schedule 4. Also want to say, okay, actually, one thing it is actually slightly more related is, oh, look. I don't bring it up. I don't check this as much as I used to, but if you kind of see this button, the wish you first to AC, if you click on it, you actually get 10 lead coins. Whether that's useful or not, that's up to you. But anyway, on the last contest, we talk about grinding a lot and stuff like this, and I was able to solve something with literally 1 minute and 20 seconds left to go. So and if you could watch that video, the contest video, I was just kind of grinding the entire time, right? Very slowly, but still, sometimes that matters, right? So definitely for y'all, spend all the time, don't give up. And honestly, if you watch some of my older videos as well, I don't even give up after the contest. I just keep going and see if I can learn from it and solve it. There's still a problem in which I haven't solved yet. But anyway, let's take a look at today's problem. Okay, so there are a number of courses that you have to take from 0 to, let's just say n-1. You're given away prerequisites, okay. Can also be indirect, okay, fine. You're given a queries for whether use of J is a prerequisite of, okay. I mean, I assume that this is a DAG. Let's double check, because otherwise, I don't know what happens otherwise actually, but okay, there are no cycles, so it is a DAG. Pairs are unique. I think the weird thing about this one is that there are at most 100 courses, and what that means is that you can just do something like Floyd-Warshall or something, right? Or not? That's not even Floyd-Warshall. That's just Warshall's algorithm, right? There's a thing. I mean, I know people. It's easy to say Floyd-Warshall because it's fun to say, but there's also Warshall's algorithm, which is actually very similar to Floyd-Warshall. We just wipe. You could see why it is, but Warshall's algorithm. Maybe am I spelling that right? Hopefully I'm spelling that right. But yeah, it allows us to calculate what we call transitive closure, right? Transitive closure just means, well, there's the transitive property, which we actually talked about like a couple of days ago. Transitive on something that's kind of unrelated. It wasn't graphy thing, but basically, if there's some function a of b, and if this is true, and f of b of c is true, then it implies that or ac is true, right? So if this is true, then if this is true and the first two, English is hard. If this is true and this is true, then it implies that this is always true. So that's the transitive property. And a transitive closure is just, what is the formal definition? Maybe I don't know the formal definition anymore. But basically, it's just kind of close the loop, if you will. And in this case, there are no loops, so maybe that's actually confusing. But just making sure that, all these things are true, right? And the way to do for Warshall's algorithm is actually very similar to, in fact, it is identical to Floyd-Warshall's algorithm, except for it's with booleans. And I actually don't know the history of this, but if I have to guess, it's probably Floyd-Warshall probably used Warshall's algorithm and applied it for shortest path in right? So anyway, so yeah, so you may have something like dp of ij is equal to dp ik and dpkj, right? And this is just Boolean values, and that's really all there is to Warshaw's algorithm. If you know Freud's Warshaw, then you probably know Warshaw's algorithm to a degree. You can kind of prove this with dynamic programming, but today we will not go over that. Anyway, so that's Warshaw's algorithm, pretty sweet and simple. The only thing that people might get wrong often is just messing the order, because I think one thing, at least this is true for me, I don't know if this is true for other people, but when I was younger, when I was learning this, I sometimes get the for loops wrong because I'm thinking of matrix multiplication, which this bears a very close resemblance to, though maybe you should not do the n cube matrix multiplication, but that's besides the point. There is a divide and conquer ways, but anyway, that's another of a sidetrack. Anyway, yeah. So you can do this, and you'll be fine. Just make sure you get the loops right. It's very precise. Okay. So then now for this one, we have, what are we doing? We have prerequisite. So these are just edges, meaning that A has to come before B, right? So that means that whether U is B. Okay. So yeah. So then we just set it up, right? So for U, we in prerequisites, right? Then we have dp of u v is equal to true, right? That's it. It just means that u has to be before v, and yeah, and of course we can just also set this up to false times n for yeah. That's it, I think. Yeah, and then now for queries. We have an array, and then we just literally just append the void Warshaw. So after we calculate the transitive closure, and then I'm wrong. Why not set? Do. Oh, this is an or. Should be this. Whoops. Still find a way to make mistakes, so I don't know what's going on. But yeah, it's whether it's already possible, and then whether there's you could go for an intermediate and go through it. But yeah, okay, so that looks good. Let's give a quick submit, and there we go. Very slow. The reason why it's slow is because it is n cube. But given the n is 100, I'm not going to worry that much about it. That said, can you do better? The thing is that you can do things that are a little bit more input sensitive. So, I mean, in the worst case, it's going to have the same complexity. But the reason why you can do better is because they're more input sensitive, right? And what I mean by that is that we're doing n cube, which is actually, I guess, not the input, really. But, or n is not the input. But if you are doing something more like if you use what's that algorithm, that 3E? Like if you use what, I'm blanking out on the name. It's named after a lot of people, but basically yeah. But there, you can also use a VE algorithm with what is that name? I'm blanking out. Hang on. I am there. Bellman Fort, right? Look, it's late in the night. Wow, it's actually really late in the night. How am I still up, or why am I still up? Also, my foot hurts, that's why. But you could use something that's similar to Bellman Fort to kind of update all these things to calculate the transitive closure as well. And that's it. I mean, that would be more input sensitive, and I'm sure there are other things you can do to make it, you can also do, like just a regular depth first search on each node. Maybe that is v plus e, right? Is that v plus e? That doesn't. No. It can be v plus e because you have to pre-calculate all of them. You have to do it so then it's v times v plus e, which is v times e, right? So if you do a depth first search from each node, and then pre-calculate it. So that'll be v times v plus y or something like that. So yeah, which of course v times y is going to be v cubed, right? If y is a full graph with v squared, but it is more sensitive to y, which is the size of the input in this case. So without that. Anyway, that is it. That's all I have for today. I'm going to keep it a little bit short. I think if this is a little bit too quick, definitely look up some algos on transitive closure and Warshaw's algorithm, and maybe even Floyd Warshaw. That is all I have for today. In a lot of pain. I don't know. Yes, I don't know. Maybe I gotta do something about it. But that's all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see you out later and take care. Bye-bye.